tema dell'utilizzo di questa commodity, questa materia prima ormai che sono i dati, la loro correlazione con l'intelligenza artificiale che abbiamo imparato a conoscere in questo pomeriggio in molte sue sfaccettature, e lo facciamo con un altro esperto di fama internazionale, César Hidalgo, che è Collective Learning Group Director all'MIT e fondatore di Datawheel, quindi professore del Massachusetts Institute of Technology, autore di bestseller, e che si è specializzato proprio nell'analizzare il modo in cui le società, gli enti, le imprese private, le amministrazioni pubbliche, gli stati organizzano in modo efficiente i dati per arrivare appunto a dare un senso a questa materia prima oggi così abbondante ma che va gestita. César Hidalgo.
Thank you. Grazie.
Agile.
Okay.
Perfetto.
Hello, and thank you for coming to this talk. So my name is César Hidalgo, and I run the Collective Learning Group at MIT. And one of the things that I try to do is to try to use data in a positive way. So I've been exploring for many years how to use data to create tools that allow that data to be distributed more efficiently, to be used to make decisions. But also, this work is leading me now to use this data for artificial intelligence applications and to question how people judge these applications and how they judge their mistakes. So I built many platforms throughout the years together with my team. We build platforms that help integrate data at a country scale and help distribute it through interactive visualizations. And what I'm going to do today is I'm going to tell you what are the design principles that are behind these data platforms and also how we're starting to use them to create artificial intelligence tools. Okay? So the problem that we try to solve is quite simple, but actually quite common. And this is that a problem that affects all organizations that are large, no matter if they're in the public sector or in the private sector. And this is that to inform decisions, organizations in the public sector and in the private sector need to usually merge multiple streams of data. Okay? And merging, matching, analyzing, and visualizing data that comes from multiple different sources in general is quite costly. So a classic example of this are governments. Okay? Governments, by definition, they're federated. Doesn't matter if it's a democracy or if an autocracy. Governments, because they're large, they're going to have many different departments. Those departments are going to have different units, and each one of those units is going to be responsible for collecting and generating a different set of data. So, for instance, if you're thinking of a government like that in Italy, you're going to have some data about health that is going to be in hands of some health authority. Insurance providers are also going to have some information. Hospitals are going to have information. But if you're thinking about economic data, well, data about exports is going to be part of the customs authority. Data about employment maybe is from the Social Security Administration and so forth. So integrating all of this data is the first challenge that we need to solve. But once we've integrated that data, we have not yet arrived to a place in which we can generate insight. So we have a second challenge after we've integrated the data, which is that of how to distribute that data. The data that she might want and that he might want might be different. So we have to find a way of distributing the right data to the right people. Once you've done that, you might be able now to start analyzing the data. You have data streams that are, personalized, and you can build analytical tools on top of them to help visualize the data, to help do a statistical analysis on it, and to get to some insight. And if you're able to do all of that, you might get to a world in which you can transform those data signals into action through the process of automation. Okay? But there's a long pipeline. And at the moment, the state of the art of this long pipeline, at least when it comes to the public sector, is filled with good intentions. Okay? So if we look at a few examples from around the world. So let's start by looking at an example from Argentina. So if you go to Argentina's open data site and you search for income data, what you're going to find is a site that basically, is going to direct you to a few pages that have like a few files. You download one of these files, and what you're going to get is like a few numbers in an Excel table. This is not a data decision support tool. If you go to the United States, you're going to find a similar story. And if you go to Switzerland, you're going to also get the same. You search here for data for the city of Zurich. You find kind of data on value added by industry. And when you get to download that data, what you find is a large collection of numbers. So you cannot use these platforms to make decisions. These platforms are delivering data, but are delivering in a way that is not perfect, is far from it, and they cannot serve their purpose as decision support systems. So my conclusion is that when it comes to these tools, we have failed, we have failed also to put batteries here, looks like, we have failed to integrate data, we have failed to analyze the data, to distribute the data, or to do any automation. So what I'm going to do is I'm going to show you tools that help solve these challenges little by little. But when we fail, we always have to ask ourselves, why have we failed? Okay? And the reason why we may have failed here is because we have the wrong design paradigm. So the way that the sites have been structured is in a way in which people think of data as files. Okay? So you think that data is like this little number that lives inside a cell, inside a table. And if you think that data is just files, basically what you're going to make is sites that help distribute those files. But in reality, if we think about data more seriously, data is conveniently stored in a table, but in reality, data is not something that its purpose is to be stored in a table. The reason why we need data is because data informs the stories that we build, the stories that we tell each other. It helps us compare things. It helps us size things. So instead of thinking of data as files, what I'm going to do is I'm going to invite you to think of data as stories. Okay? So what we're going to do is we're going to create tools that help transform data into stories. And by helping transform data into stories, we're going to integrate the data into narratives that use multiple data sources. Now, if we change our design paradigm, we're going to change our software architecture. So we're going to push all of that data to the back end, and we're going to integrate it into technologies that allow us to extract the entities and the variables associated with them. So we were doing a site, for example, for Italy. Entities could be cities, such as the city of Rome or Milano or Turin. And those entities are described by multiple variables in different data sets. There might be an education data set that tells us about schooling and the quality of the universities, in a certain city. There's a different data set that tells us about employment. There's a different one that tells us about health. So what we can do is use this information to construct the stories for each one of the entities. The entities could be geographies, the entities could be sectors, the entities could be occupations, they could be even institutions like universities or firms. And that way we integrate all of this data into this narrative that is going to allow us to do two things. The first one is that because we're working with public data, we need to make sure that people can find this data on the web. And by transforming data into stories, what we're going to do is we're going to blow this data into 1,000 stories that search engines can find. So Google has no way of knowing that cell C3 of your table contains the median household income of Oklahoma. But if you give Google a sentence, the median household income of Oklahoma is $47,000, Google knows how to extract that information and knows how to push that page to the top of the search engine results. So what we're going to do here, the first thing that we're starting to get for free is that by transforming data into stories and expressing data in thousands or sometimes millions of different stories, we're making that data accessible to the people that go to the search engines looking for it. And that's going to give us a stable source of traffic. We're going to have people that is going to be able to find the information finally. The second thing that this is going to give us is the ability to build an engine that we can later use to power artificial intelligence. So think about the second industrial revolution. The second industrial revolution was based on electricity. Okay? But for electricity to be useful at home, people not only needed appliances, they not only needed refrigerators and dishwashers and laundry machines, they also needed to get electricity into their home. And since electricity was difficult to produce, people had to create big power plants and distribution systems that distribute that electricity to the homes where those appliances are. Well, in this world of the fourth industrial revolution, the appliances are the artificial intelligence algorithms, and the power plant is the data. So you need to build, these distribution systems that can either push the data to the edge where the algorithms are going to be, or that, can bring the algorithms in to do calculations. In any way, you need to produce, some sort of system to connect algorithms to data such that those algorithms can be trained and can be up to date. Okay? So that's the second thing that we're going to get. So let's look at a few examples. Okay? So if you go to Google and you search for the exports of Canada Italy, United States, or any country, the first page that you're going to find is not a page from that country, it's not a page from the World Bank, it's not a page from the IMF, you know? It's a page that we serve from a humble server at MIT that has grabbed all of the world's international trade data and has transformed it into thousands of different stories. You know, this is the Observatory of Economic Complexity. This is a project that we created in the year 2011. You know, it's actually 9 years old by now, and help people understand how the economies of countries are expressed in different products. They help us understand the knowledge that a country has based on the products that they're able to make. If you're interested more on that part of my work, the books that I've written about this, Why Information Grows, or its Italian version, L'Evoluzione dell'Ordine, are for sale back there as well. But today I'm not here to talk to you about how economies evolve or how they change their productive structure. I'm here to talk to you about the tools that we build to help describe data at large scale. So after we built the OEC, we realized that people were interested on these tools, not only on the messages that these tools provide. So we built many tools like that since. In 2016, we created Data USA. Data USA is a very interesting platform because it not only makes available economic data, it integrates data on the economy with data on housing, on health, on transportation, for all of the United States, at multiple levels of the hierarchy. It is available for counties, for metropolitan areas, for states, and for industries and occupations all across the hierarchy. In 2017, we created Data Africa, which integrates data for 13 African countries. In 2017, we created Jobs KSA. This is a tool that grabs all of the social security data of the Kingdom of Saudi Arabia and creates, indicators of employment for every industry, location, and occupation in the country. And is used to strategize job creation strategies. In 2018, we created Data Chile, which integrates data from more than 15 different government departments. And in 2018, also, together with the government of Korea, we helped them create Data Korea. And Data Korea also integrates data for all of the Korean nation. So we created this and other projects. We're finishing now one for the government of Estonia. And we have also done similar projects for the private sector. So this one I show it very little because it's actually private sector data. So this is for a large cosmetics company that has multiple brands. It's the largest cosmetic company in the US. And what we've done is created a similar platform that integrates data from multiple sources, data on sales, data on projections of sales for different markets and segments and forms and so forth, and allows their executives to actually see the information that their company have so they can inform their decision, to understand which markets are growing, to understand if the products that they're sending to certain distributors are properly allocated, they have the right shades, the right colors, the right forms and so forth that are being demanded and whatnot. Now, do these strategies work? Does it work to search engine optimize data to transform it into stories, by transforming it into stories? So here you see the traffic to the Observatory of Economic Complexity since the moment that we launched it in 2011 until sometime last year. And you see that the traffic goes up over time. It goes down during the summer vacations, it goes down during Christmas. There's not so many people, searching for trade data on December 25, but overall the traffic goes up. The site is way more popular today than the moment that it was launched. And what this is telling you is that actually we created a tool that has a stable and recurrent source of traffic. This tool is being used, by governments across the world. It's being used by bankers. We get a lot of emails from bankers, across the world that they use this information, to price, commodities or to price bonds. And also is being even used by the team that makes the briefing for the President of the United States. Okay? So they visited me at MIT a few weeks ago, and they told me that they're big fans of the OEC, and they're also big fans of Data USA. Because Data USA also has helped, make this information available, and also has helped search engine optimize that data. Come on, we can do it. Okay. Okay, so here is the traffic to Data USA. And when Data USA was released, it also had a lot of traffic. In that case, we got, to be on the New York Times. We were the most shared news of the Atlantic that day. We were in Fast Company. There were dozens of blogs being written and many tweets. But the traffic that you get the moment that you launch is not sustainable. You're going to launch, you're going to get some attention, and that attention is going to go down. And you need to have a way to sustain that traffic over time. And what we show here is that by this idea of transforming the data into stories and helping those stories search engine optimize the data, what we can do is we can actually generate sources of traffic that are much larger, much more stable, and of course of much better quality than the traffic that we get if we only are using referrals or media attention. Now, can you pass the next slide, please? Oh, okay. So with that, we've won the challenge of integration. The challenge of integration, it's a challenge that we're able to accomplish when we transform data into stories, because when you read a story that uses multiple sources, you're going from one source to another smoothly. Yeah? So you're reading about a certain location like New York, and you're looking at data from the census, then you're moving into data, that comes from a health authority, or data that comes, from the Bureau of Economic Analysis, and the story integrates all of that information. But the problem is that the distribution challenge is still not met because the data now is trapped into these little boxes of visualizations, So the user might want to combine data in ways that are not present in these profiles. So you have another challenge now, which is of how you allow users to distribute that data. Okay? So what we're going to see next is a feature that allows us to distribute this data, which is the data integration card. So if you go to Data USA and you look at a data set, what you're going to find is that every time you find a data set, you're going to have like this little button somewhere in the page that says add that data to cart. So, for example, here you're looking data on poverty, you add it to cart, but you can also go to the profile pages and look at the data that is there, to integrate it with other data sets that you found on the site. So the idea is that these profile pages are not just ways to display the data, but are kind of like the aisles of a supermarket of digital information. And as you're browsing down the aisle, as you're walking down the aisle, you add the data to cart, and what Data USA does is integrate all of that data for you so that you can download a custom data set that uses only the data that you're interested in. And with that, we solve that challenge of distribution. Because now every user can go to Data USA, they can select the little boxes that they want, Data USA integrates them, and then now they have an output that is custom to their needs. But there is still the analytical challenge. So this year we released a new feature of Data USA, which is the visualization builder. And this is a completely general feature. It looks very simple on the surface, but actually it's quite complex because even the user interface of this tool, is being derived directly from the database. So we have these all-up cubes, are these technologies that allow us to create many different materialized views for data. And what we're seeing here is someone that is cutting this data iteratively. So it's looking at the population of the United States, then it cuts it by state, then it cuts it by gender, then it cuts it by race, and then it cuts it by occupation. And you can get to like that deep query, say, well, how many black females work on the software industry by state? That information is not available in the profiles. It's too detailed to put it on a profile. But with this type of technology, that is quite general, we can allow users to get any of those cuts and go much deeper into the data than ever before. So what we've been doing is also using this type of information to create experiences that can help improve decision making. And what I'm going to do next is I'm going to show you an example that we have been working together with the government of Argentina and with the Inter-American Development Bank. So what you see here is a map of Argentina. You see Buenos Aires there, shows very prominently next to the Rio de la Plata. But what I'm going to show you next is a map of the hospitals in Argentina. So you see where the population of Argentina is, now you see where the hospitals are. And by putting those two together, we can actually create some index that allow us to figure out how many people are far from hospitals, how many people are you sharing a hospital with, and also, if the capacity of the hospital is too low for that population. And by doing that, we can find where there are gaps on public investment. And these gaps on public investment, we can derive them in different ways. We can look at the total gap For instance, in this case, we can see how many people are there and how much gap do they have as a whole. Or we can do something that is more redistributive and figure out which are the people, even though they might have a small population, that have the largest gaps. You know? So what we're doing with this tool is basically starting to create a platform that allows to identify gaps in health, that allows to identify gaps in education, both physical gaps as well as monetary gaps, and help us anticipate, predict, and suggest, potential public investment. So you now see how by creating these data tools, we get to a world in which we can have decision support systems in which artificial intelligence becomes part of the equation. But the question that I'm going to ask next is, well, if we're creating these tools that are going to become new actors in our society, if in the future we're going to live in a world in which machines are also, part of our labor force, they're not only, working with us in our warehouses, they're even dancing, or, they're even making mistakes, So machines are not always perfect. Sometimes they make mistakes, So here you have a machine doing something that is more human than the previous machines. And the question that I'm going to ask myself is, when machine makes mistakes, when we integrate them into our society, but they also fail, how is it that we judge them? Okay? So we're going to live in a society in which robots are going to be part of our society. And the question that I'm going to ask next is, well, in this society, how is it that humans judge machines? So AI ethics, as you know, has become a hot topic. There are many articles that are being written in the popular press and in the academic press about AI ethics. And if you want to understand this literature, one easy way to parse it out is to think that there are like a few different links. On the one hand, you have people that have been studying or asking the question, how should the machine behave? Okay? How should the self-driving car behave? Should it try to save the driver? Should it try, to avoid, like hurting any pedestrians in situations that are contested and so forth? So these are people that are trying to figure out what should be the internal ethics of machines. But that's only one of many questions that you can ask on that domain. There's other people that are interested in the questions of algorithmic bias or fairness, and they're asking the question, well, when machines are interacting with us, are they doing it in a way that is fair? Or are they doing it in a way that perpetuates bias that we already have in our society? Bias with respect to gender, with respect to ethnicity, with respect to nationality, with respect to occupations, and so forth. But if we're asking ourselves, well, how should the machines behave? And are machines being fair to us? One thing that we need to ask ourselves also is, well, are we being fair to machines? How is it that we judge machines? Because if we're going to be imposing our morality on machines, we have to understand if we're also doing that in a fair way. Do we tend to be forgiving to machines, or do we tend to be harsher to them? And honestly, this is something that we still don't know. So together with my team at MIT, what we started doing is collecting data on how humans judge machines compared to how humans judge other humans committing the same mistakes. The way that we do this is by using a classical technique of experimental psychology, in which we present people with scenarios in which an action is being performed by a human and the same action is being performed by a robot or an artificial intelligence system. Okay? So let me show you an example. So in this example, we see in a subway station, an officer or computer vision system sees a person carrying a suspicious package who matches the description of a known terrorist. The officer or computer vision system is unsure of the identity of the suspect, and it points a weapon at the suspect and orders him to stop. The suspect does not understand English and reaches into his pocket for identification. The officer or computer vision system feels threatened and unloads the weapon, killing the suspect. A subsequent investigation reveals that the suspect was not a terrorist, but a foreign businessman on his way to the airport. So we present, one version of this scenario to 200 people, showing it as the action of a human. But there's another group of 200 people that sees the same scenario as the action of a machine. And then we ask people to evaluate this scenario based on in general, about 11 questions. Was the action harmful? Was it intentionally? Was it morally wrong? And so forth. You know? So what we're going to do is we're going to see how people judge humans compared to how they judge machines. And we're going to do this by comparing what is the average response that people provide in the case of a human action compared to a machine action, holding all else equal. Okay? These are balanced groups. They have been randomized, you know, but also the question is all the same except for changing just one noun, you know, the human for the machine. And what we're going to do is we're going to see, well, when these differences are significant and how large they are. So going forward, every like red dot represents how people are judging a machine, and blue dots show how people judge a human committing the same action. And when those two little bars separate, it means that there is a significant difference, and when they're highly overlapping, it means that actually people don't see this as any difference. So what do we find in this subway scenario? Well, when we look at the harm dimension, which is the first question, was this action harmful? People think that when that extrajudicial killing was performed by a machine, they see it as more harmful than if it was performed by a human. Of course, in both cases, the value is very high, but actually, it's a little bit significantly higher in the case of a machine. When we ask people, would you hire that machine? Or would you hire that police officer? People don't want to hire that machine, but they're not so harsh with that police officer. We see a large difference. Do you see this action as intentional? And surprisingly enough, they assign as much intention to the machine as they assign to the human. They see them equally in intention dimension in this case. Then we ask people, you know, do you like the officer or do you like the computer vision system? As you can see there, they like the officer much more than they like the computer vision system. Was this action morally wrong? This is a really important question. This is actually the question about the moral judgment of the action. And in this case, they find the action worse when it was the action of a machine. You know? Would you promote this officer? Well, if it's a robot, for sure not. If it's a human, it has a small probability. Would you have done the same on a similar situation? And when we ask people, would you have done the same on a similar situation, they're more likely to feel identified with the action of the human than the action of the machine, even though the action was the same. So now you get an idea of the methodology that we're using to compare human and machine actions. You know, the last part of the methodology that I'm going to share is that these scenarios are not all the same. There are many ways in which an action can be morally wrong. You know, and there are 5 to 6 moral dimensions that moral psychologists have discovered. You know, some things can be morally wrong because they hurt other people, and that's the harm dimension. You know, but other things can be wrong because they're unfair. But things can be wrong also because they're unloyal, or there is a disrespect of authority, or because they violate the purity dimension. So what we do is we run a separate experiment in which we ask people to associate words with each one of these scenarios to figure out what moral dimensions they trigger. In the scenario that we saw before, the one of the subway, this is a scenario that is about harm and fairness. There was a person that was killed, and he was killed unfairly. Okay? So this is a scenario about harm and fairness, not about loyalty, not about purity, not about authority. So now that we have the building blocks of our methodology, we can start looking at real examples. And real examples are going to come in groups. You know? So the first example involves decision making under uncertainty. You know? And like the uncertainty that I'm facing every time I click this button. You know? Yeah. Boom, boom, boom. Yeah. Can you go to the next slide, please? Okay, thank you. Yeah, one back. Okay. So consider the following scenario. A large tsunami is approaching a coastal town of 10,000 people with potentially devastating consequences. Okay? The politician or algorithm responsible for the safety of the town can decide to evacuate everyone with a 50% chance of success or save 50% of the town with 100% success. Okay? So you have an option here, you know, of saving everyone that is risky, because you can succeed or you can fail, or to take a compromise and save half of the people, you know, in an action that you know what outcome is going to get. You know? So these are 3 scenarios. In one world, you know, we present people with a scenario of failure. The politician or algorithm decides to save everyone, but the rescue effort fails. The town is devastated and people die. Then there is another case in which the politician also decides to save everyone, but they succeed and everyone is saved. And the last example is, well, the politician decides just to save 50% of the people and we'll know what's going to happen there. They're going to get that 50% and that 50% is going to get sacrificed. So how do people judge these three scenarios? Here, we look at the three scenarios in parallel, in the case that, there was a risky decision and a failure, a risky decision and a success, or when there was a compromise. And the first thing that we see is that, when it comes to the success scenario or the compromise scenario, the outcomes are not that different. But when we look at the failure scenario, we see a large number of important differences. So once again, we find that in this case, people judge the action of the machine as more harmful than the action of the human, even though they both run the same risk, and they both failed. When it comes to hiring that politician or hiring that algorithm, in the case of the politician that took the risk and failed, people actually evaluated positively. They evaluated above 0.5, above, the central point. But in the case of the machine that took the risk and failed, people see that as something negative. When it comes to intention, we see there in the success dimension, there's a big difference. So when you took a risk and you succeed and you're a human, they think that you were doing that with intention. If you take a risk and you succeed and you're a machine, well, they see it as kind of like something more accidental. You don't get the credit for it. Yeah? Do you like the machine? Do you like the algorithm? Or do you like the human? Well, in the case of failure, they like the human much more than the machine. Once again, here, the human is rated positively and the machine is rated negatively. Was the decision made morally right or morally wrong? In the case that there was a risk and there was failure, the decision is seen as morally wrong more frequently when that was the action of a machine. Would you promote that algorithm? Would you promote that politician? Well, the politician is more likely to get re-elected than this algorithm, even though they committed the same mistake. So this is interesting because it tells us that the way in which we judge humans and machines is different when we are in situations that there's a large degree of uncertainty and there's failure in a risky action. Yeah? We, in this case, judge machines much more harshly. Yeah? The machine actually, is getting short. And one question that you might have is why? Well, here we can use some basic ideas from moral philosophy, which are the ideas of moral status and the idea of moral agency. A moral agent is someone that makes a moral action. Okay? So it's the actor that is performing the action in a moral dilemma. Moral status, applies to the ones that are receiving the action. And it's the idea that there are certain agents that you cannot use as a mean towards a goal. So, for instance, you cannot kill someone as a mean to save other people, because people have a moral status, so you cannot use them as a mean towards a goal. But maybe killing a dog to save people is something that people would accept because the dog has lower moral status than humans. Yeah? So how do these ideas of moral agency and moral status help us explain what we observe here? Well, think of this action in the context of a politician. You have a tsunami that is approaching a town, and the politician is trying to save everyone but fails. Why would the politician try to save everyone? Well, because the politician is a moral agent that is acknowledging the moral status of other people. He's trying to save everyone, even though that might be risky, because the politician in this case is a human that has a heart. He's trying to make the right decision, even if it's risky, because he's acknowledging that other people are valuable and they have moral status. So in the case that the politician fails, they still try to do the right thing. They got the wrong outcome and try to do the right thing. Now apply that to a machine. When the machine tries to make that decision, when they take the risk and fail, people probably don't attribute that the machine is acknowledging the moral status of other people and is trying to make the right decision. They see a machine that makes a wrong calculation. So the politician has heart and make a decision that was risky and failed. The machine, since it doesn't have a heart, basically if it failed, it's because it didn't have the right brain. And it gets judged much more harshly. So let's look at another example. This goes into the space of marketing. So these are not harm moral dilemmas, but purity dilemmas. In the first one, which is an ad from Benetton, we have the following scenario. A well-known clothing company wants to create a high-impact commercial. It desires to hire a new marketeer or an AI marketing system to design an image that combines rivalry and love. The results are the images below, which cause shock and outrage among the members of the public. Similarly, a public transportation company also wants to do an ad that plays on the word riding, and they produce the following ad that is clearly inappropriate. Finally, there is another clothing company, in this case, want to illustrate the addiction to clothing, and it does so, with the ad that we see here. Also, people get upset at that ad. So when we look at these moral dilemmas, nobody's getting harmed in this case, but it's a dilemma that mainly focuses on the dimension of purity. These are actions, that in some sense violate something that some people would consider sacred about the human body, maybe sacred about heterosexuality, maybe sacred in the body in the context of drugs. Even though these are not real drugs, that's a t-shirt that they're sniffing there. Yeah? So how do people judge, machines in this case? And we find that in general, people judge machines very similarly than they judge humans. So they don't make a big difference in how morally wrong they think the machine action is to the human action, but they do make strong difference in two dimensions. We ask people, well, when this mistake happens, who should respond to the public? Should the company respond to the public, or should the marketeer respond to the public? And also we ask, well, who's responsible for the action? Is it the marketeer or the marketing algorithm, or is it the company that hired it? And what we find here is that when you use AI, responsibility moves to the central actors of the decision-making chain. Okay? So when you use AI, people think that now the organization, not the marketeer, is more responsible. And what this tells us is that one of the consequences of automation that we need to face is that we're going to stop shielding ourselves from responsibility by outsourcing jobs to other people. Because when you outsource a job to someone else, it's not simply that you are dividing labor, you are in a position in which you can take credit for the work of others if it's successful, and you can be excused of the failure of others because it was someone else's failure. But when you outsource that job to a machine, you are going to also bring to yourself more responsibility than before. And that centralization of responsibility is one of the things that you're going to need to consider in a world in which autonomous agents become part of our labor force. Let's look at another example. The last example involves self-driving vehicles. Next slide, please. Hello, next slide. Yeah, so thank you. Yeah. On a sunny spring day, a driver or a driverless car working for a supermarket chain accidentally ran over a pedestrian who runs in front of the vehicle. The pedestrian is hurt and is taken to the hospital. Then we have the same scenario involving a dog, lower moral status. On a cold and windy day, a driver or driverless car working for a supermarket chain swerves to avoid a falling tree. By swerving, the driver or driverless car loses control of the vehicle, leading to an accident that seriously injures a pedestrian on the sidewalk. Then we have the same example using a dog. So this is, once again, is a harm situation, but these are both situations in which the car in some sense doesn't have too much responsibility. Yeah? So in the first case, the pedestrian or the dog jump in front of the car. In the second case, there is a falling tree and the car is doing a maneuver to try to avoid the falling tree, and that's how they get in the accident. So the accident is triggered by an external event. How do people judge machines and how do they judge humans in this situation? What we find here is the following. On the one hand, we recover what we found before. In scenarios involving the harm dimension, people see the action of the machine as, in this case, slightly more harmful than the action of humans. But what is interesting here is what we find in the intention dimension. In all of the other examples, we tend to find that in general, people assign a little bit or a lot more intention to the human than to the machine. But in this case, they assign more intention to the machine than the human. And that's kind of puzzling, because logically we know that machines cannot have intention. Yeah? that are a little bit dumb in that case. But in this case, what we find is that they assign more intention to the machine, not because they assign a lot of intention to the machine, but because they excuse the human more. So when the human commits a mistake in this kind of accidental situation, the human is completely excused, from the moral action much more than the machine. So the machine gets attributed more intention and also is seen as more morally wrong, they like it less and less likely to be promoted. So once again, the machine gets the bad side. But are there situations in which people judge humans more harshly than they judge machines? So now let's go to our fourth and final example involving the moral dimension of loyalty. So this is an example that we borrowed from one of Jonathan Haidt's questionnaires, and we say a family has a cleaner or robot in charge of cleaning their house. One day, the family finds the cleaner robot use an old national flag to clean the bathroom floor, and then threw it away. So in this case, this robot or this person is doing something that is disrespectful of a national symbol, but nobody gets hurt when someone, is disrespectful to a flag. It's also not unfair, might have some sort of purity component, but in general, it breaks the loyalty towards the group. We respect flags in the context of a group. Doing this action as an American is very different than doing this action as a member of ISIS. Yeah? As an American, you're expected to be loyal to that group. As a member of ISIS, you expect loyal to be a different group. So this actually breaks, that loyalty dimension. So we have other examples in which also we have some form of desecration of national symbols. A demolition crew demolishes a school, and when they demolish a school, there is a flag that was there that also gets captured. In one case, that flag, that demolition crew was autonomous. In the other case, it was a standard demolition crew. During a major sporting event, the operator or algorithm running the public announcement system interrupts the national anthem to announce a badly parked vehicle. In an international sporting event, the operator or algorithm running the public announcement system plays the wrong national anthem for one of the countries. Okay? The fans, of course, get annoyed. So what do we find in this case? And here we find something very interesting. We find kind of like some sort of seesaw effect. Okay? So when we ask people, well, what is the level of intention that you attribute? In the case of the school demolition, they attribute very little intention. So if there's a demolition crew that demolishes a school and fails to notice a flag, people see that as accidental, whether the demolition crew was autonomous or whether the demolition crew was operated by humans. But when we go to the anthem interruption, there they attribute, much more intention to the human than the machine. And when we look at the robot cleaner, there's a strong difference in intention between humans and machines. And as intention differentiates, morality also separates. So in the case of the school demolition, they see the action equally morally wrong in the case of a human action or in the case of a machine action. But in the case of the robot cleaner, they see the action as worse when this is the action of a human. So in some sense, we find kind of like a counter example of what we found before. In all of the previous examples, robots were being treated more harshly. But when we have intentional violations of loyalty, even though people don't like disloyal robots, they like disloyal humans even less. So this is all part of a new book that I'm working on, which is called How Humans Judge Machines, that includes more than 80 scenarios on machine ethics and tries to understand how we judge, machines different from how we judge humans. And there's a few takeaways. We know that in scenarios involving physical harm, humans tend to judge machines more harshly than other humans. So if you are involved in a case of automation and that automation has some sort of physical risk, you should be very careful because any backlash that you're going to get is going to be worse than if you have done the same mistake, with a team of people, performing that action. In scenarios involving fairness or loyalty, however, humans judge other humans more harshly than machines. They kind of like expect machines to understand or respect physical harm, but when it comes to fairness or loyalty, we tend to judge other people more harshly than machines. In scenarios involving uncertainty, like in the case of the tsunami or the self-driving car, in that case, humans judge machines more harshly. So if there's uncertainty involved, machines tend to, get the shorter straw. And in scenarios involving automation, responsibility moves up the chain of command. So if you think of a world in which you're going to introduce automation into your company, be ready to accept a higher degree of responsibility for those actions. And with that, I would like to thank you very much for your time. I'm happy to take any questions or comments. Thank you. Yeah. Yeah. Thank you.
Thank you.
Thank you.
Two questions, but it's just one. The correlation between the data managing tools and this relationship between human and machines with democracy. Because you need transparency and democracy to have data. Otherwise, you don't have them. I think it's difficult to have this kind of tools you showed us in China or in North Korea. And on the other hand, is there a risk of automatic decision-making, which is, at the end of the day, a dictatorship of data? For example, I want a wage raise. No, because data show that in your region, wages are blah, 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 so I cannot complain anymore. So this kind of correlation between data managing and democracy.
Yeah. So when it comes to the tools, I wouldn't say that these type of tools are exclusive of only democratic instances. It might be governments that have a higher technocratic capacity. When I visit China, I do think that they're very advanced in the use of data in decision making and so forth. When I visit North Korea, not that much. Okay, but it's not.
But they're available in China. Data are available to public, for example.
Actually, like in China, a lot of economic data is available to public, and they sell it. Because they have a different distribution system, which they don't make the data available for free, but they sell it to private sector organizations or to researchers as a way to kind of like pay back for that data collection issue. At the same time, Europe is very democratic, but if you go to Eurostat, it's not the best platform to download or browse, public data. So I do think that they're not necessarily aligned, like government capacity and type of regime are variables that they might correlate in some way, but not perfectly, and a lot of the differences in implementation that we might find here might be more of a function of government capacity rather than the type of system.
And the other question, the risk of automatic decision making. Machines.
So that's something that we need to be very careful, of course. Like we don't want data and AI to come and replace us. And I think we're going to be able to do that because AI is here to serve us. We're not here to serve it. But we have to be careful because when we train these algorithms, of course, they're going to encode many of the biases that we have in the previous data. There's many people that have been looking into this. There are already algorithms that are used, for example, for parole decisions in the United States, and they have been very controversial. And there's a new field emerging to try to understand, how to better do this. There are some interesting papers by Mulainathan and Kleinberg and other scholars, in the United States. And what is counterintuitive, but a powerful theoretical result that they obtained, is that some people thought that the way to make the systems fair is to hide some data to them, okay? And what Mulainathan and Kleinberg have shown is that actually that is not correct. You want to separate the problem of predictability and fairness. And the way to make a system fair is to make it as predictable as possible using all of the data that you have available, no matter even if that data includes demographic dimensions that might cause some certain bias. And once you have the maximum prediction, you do the fairness as a second step. And they show, mathematically, that if you basically sacrifice predictability to ensure fairness, you get a result that is less fair than if you maximize predictability and do fairness as a second step.
Thank you, César Hidalgo.
Yeah. Thank you.